We'll start in 1 minute. Today we'll start working on the sample final exam that I emailed, and the final exam is scheduled for Monday, May 4th, from 3 p.m. to 5 p.m. There's more information about the final exam that we're still waiting on, and I'll let you know when I know. Okay, for a bunch of the problems, I rewrote them that are on the sample final. So on this one, number 1, true or false? Log base 2 of 7 times y to the third equals 3 times log base 2 of 7y. This is false. The left-hand side, if you expand the left-hand side, it's log base 2 of 7 plus log base 2 of y to the third, and so on. But the right-hand side is 3 times log base 2 of 7 plus 3 times log base 2 of y. So you could expand this part a little bit further. Log base 2 of 7 plus 3 times log base 2 of y. Well, I messed that up. Anyway, the two sides are not equal, so this is false. Okay, the next one, f composed with g of a equals f of a times g of a. That is false. F composed with g, this is f of g of a. But in general, that does not equal f of a times g of a. Okay, the next one, given that g of x equals x squared minus 1, true or false? G of 0 is greater than g of 1. Well, we can compute g of 0. G of 0 is 0 squared minus 1, which is negative 1. And g of 1 is 1 squared minus 1, which is 0. And it is false that negative 1 is greater than 0. So this one is also false. Number 4, the graph of this rational function, r of x equals x squared minus 2x minus 8 over x minus 7 has a slant asymptote. That is true. The reason that we know that is because the degree of the numerator is exactly 1 more than the degree of the denominator. So if you divide the numerator by the denominator, the quotient is a straight line with non-zero slope. So that's the quotient is the slant asymptote. Number 5, true or false? Functions f of x equals the base 10 logarithm of x, and g of x equals 10 to the x are inverse functions. This is true if you just find the inverse of one of those functions. Y equals log the base 10 log of x. So I just wrote in 10, not required. Then if you interchange x and y, x is log base 10 of y, then convert this to its exponential equivalent. 10 to the x equals y, or y equals 10 to the x. So they are inverses. Number 6, true or false? Y equals 2 to the x minus 1 is a polynomial function. This is false. This is an exponential function. If the domain variable is in the exponent, then it's an exponential function, not a polynomial. True or false? Number 7, negative 2, 0 is the y-intercept for the function. F of x equals 3x squared plus 4x minus 2. This is false because every y-intercept has an x-coordinate of 0. So the real y-intercept is 0, negative 2, but not negative 2, 0. Okay, number 8, true or false? Given the function y equals f of x, then y equals f of negative x is a reflection across the y-axis. Some words are left out, but if we understand what is meant, then the answer is true. The graph of f of negative x is the graph of y equals f of x reflected across the y-axis. Okay, for number 9, if f of x is 3 minus 2x, then find f of x plus 2. So that just means in the function f of x, replace x with x plus 2. And then you can simplify a little bit. This is 3 minus 2x minus 2 times 2 is minus 4. And then you can simplify further and write it as negative 2x minus 1. Okay, the next page, number 10. Evaluate capital F of negative 2, where capital F of x is the piecewise defined function. We're going to evaluate f of negative 2 depending upon which piece the domain value negative 2 is in. So at the very top, the domain values for the top piece are x less than or equal to negative 2. So that means to evaluate f of negative 2, we're going to use the top piece. So f of negative 2 is 9 times negative 2 plus 12, or negative 18 plus 12, which is negative 6. Okay, and number 11, simplify x minus 2i times x plus 2i. Multiply those like the same way that you would multiply any two binomials. So x times x is x to the second, and then plus 2ix, and then minus 2ix, and then minus 4i to the second. The two middle terms cancel each other out, but remember that I to the second is negative 1. And so when we're finished, x squared minus, I'll write it, x squared minus negative 4 is x squared plus 4. That's the simplified product. Okay, for number 12, a quadratic function f is defined by f of x equals negative 3 times the binomial x plus 4 squared minus 8. State in part A, state the coordinates of the vertex. The x coordinate is negative 4. The y coordinate is negative 8. State the equation of the axis of symmetry. That is x equals negative 4. This is a vertical line. X equals negative 4 is a vertical line in the xy plane, and its for a quadratic function, it's always the vertical line that passes through the vertex. And since the x-coordinate of the vertex is -4, that vertical line is x equals -4. State the domain. The domain of every quadratic function is all real numbers. So from -infinity to +infinity is the domain. And the range, well, let's see. This function opens, the graph of this function opens down. And so there is a maximum range value, and the maximum range value is the y-coordinate of the vertex. So the range is everything from -infinity up to -8, including -8. So the range is -infinity, comma, -8, bracket. Okay, number 13. The polynomial function capital P is defined by capital P of x equals -3 times x to the third times x plus 5 to the second times x minus 4 to the fourth. So the degree, if we just count multiplicities, so here we have 4, 5, 6, 7, 8, 9. So the degree is 9. What is the leading coefficient? Let's start over here on the right. If you were to multiply x minus 4 raised to the fourth, multiply that out, that would give you x to the fourth. Then x plus 5 squared, multiply that out, you would get x to the second. And so if we multiply x to the fourth times x to the second times -3x to the third, the leading coefficient is -3x to the ninth. Then it says state the zeros together with their multiplicities. Okay, so in one column I'll state the zeros, and in the column next to it I'll just list the multiplicities. So 0 is a multiplicity, or sorry, 0 is a 0 of multiplicity 3 because of the x to the third. -5 is a 0 of multiplicity 2. And +4 is a 0 of multiplicity 4. Okay, then use a calculator around to the nearest thousandth. I actually brought a calculator, so I'll just see what I get. 1.35 raised to the -0.8. Okay, then round it to the nearest thousandth. That means 4 decimal places. So I'm going to get 0.7866 when I round it to the nearest, oh, sorry, tenths, hundredths, oops. 3 decimal places is the nearest thousandth. So 0.787. Yeah, tenths, hundredths, thousandths, 3 decimal places. The natural log of the square root of 3. So round that to 3 decimal places or to the nearest thousandth. And I get 0.549. And log base 3 of 5. Well, my calculator doesn't have a base 3 logarithm, but we have the change of base formula. So log base 3 of 5, you can use the natural log of 5 divided by the natural log of 3. If you prefer, you could use the base 10 log. You'll get the exact same number. The base 10 log of 5 divided by the base 10 log of 3. So either way, natural log of 5. So rounded to 3 decimal places, this one I get 1.465. Okay, number 15, simplify the following. Log base 9 of 3. Well, with a calculator you can do that, but you don't need a calculator for this one. Log base 9 of 3 is equal to 1/2, because 9 to the 1/2 is 3. 9 to the 1/2 is just the square root of 9. Then part B, log base 2 of 1/8, that's equal to -3, because 2 to the -3 is 1/8. Log base 3 of 3 to the 5th, that's equal to 5, because 3 to the 5th equals 3 to the 5th. The next one, log base 2 of 40 minus log base 2 of 5. This is log base 2 of 40 divided by 5. 40 divided by 5 is 8, so log base 2 of 8. And log base 2 of 8 is 3, because 2 to the 3rd equals 8. Okay, the next page, number 16. And number 16, the cost of a taxi fare, capital C, varies directly as the distance, capital D, traveled. Write a variation equation that relates C and D and use the variable K for the variation constant. Okay, so if the variation is direct, then it's just C equals K times D. That's all you have to do for that one. On number 17, I decided to try to see the graph of this copy that I sent you. So this one says, answer each of the following using the graph of the function on the right. Approximate any values as needed. Determine the range. So if we can, this looks like it has an absolute minimum, which is about, I'm going to say about -1.25. And then after that, the range values go to infinity. So the range, I'll put bracket -1.25 comma infinity. Determine the intervals on which the function is increasing. So as you look at it from left to right, the intervals where it goes uphill, that's where it's increasing. So the domain interval where it's increasing here is from -9 to -5. So I'll list that, -9 comma -5. Then it's increasing on this interval from -1 to 5. So you can put a union symbol. Probably if you just put a comma, you'll get away with that. But anyway, from -1 to 5, the function is going uphill again. And then over here from 9 to infinity, it's increasing again. Part C, for which values of x is f of x equal to 0? So this is like asking, what are the x-coordinates of the x-intercepts? So wherever the graph is crossing the x-axis. So this one looks pretty close to x equals negative 10. I'm just going to say negative 10, and this one is negative 8. So x equals negative 10 and x equals negative 8 are the two x values where the graph crosses the x-axis. Okay, part D, for which values of x is f of x greater than 0? So graphically, that means wherever the graph is above the x-axis, that's where f of x is positive. And it looks like it's positive everywhere except from negative 10 to negative 8. So to the left of negative 10, we can say negative infinity to negative 10, parenthesis. And then f of x is negative between negative 10 and negative 8. And then for x values greater than negative 8, the graph is above the x-axis again. So union negative 8, comma, infinity. Okay, on part E, it says approximate f of 0. So that's like asking what the y-coordinate of the y-intercept is. And it looks like it's about 1.7. If you're in the ballpark, you'll probably be given credit. So I'm going to say f of 0 is about 1.7. Okay, part F. Part F says find the location and estimate the value of all local maxima. So what they mean is maximums, plural. So there's a local maximum here. That's where it tops out in a locality. And then there's a second local maximum. Okay, the location is the domain value that corresponds to it. So at the location, x equals negative 5, there's a local maximum of y equals about 3 2/3, say. So just be close. And then there's another local maximum at x equals 5. So at x equals 5, the local maximum is about 8.8 or something. Okay, number 18 is next. Number 18, let f of x be equal to x squared plus 5x minus 3. Compute and simplify f of x plus h minus f of x over h. So this is, I left out the words difference quotient. This is one of the difference quotients. It's just the slope of a line. Okay, so in the numerator, f of x plus h. So since f of x is x squared plus 5x minus 3, f of x plus h is x plus h squared plus 5 times x plus h minus 3. So this is what f of x plus h is. And from it, we are subtracting f of x. So I'm going to put parentheses. I'm going to subtract a trinomial, so I'm going to put the entire trinomial inside the parentheses. And then we're dividing it all by 8. So we just do algebra and arithmetic until we're completely simplified. When we square x plus h, that means x plus h times x plus h. So we'll get a total of x squared plus 2hx plus h squared. And then plus 5 times the binomial x plus h. That's plus 5x plus 5h. And then minus 3. And then we distribute subtraction. We subtract x squared. We subtract 5x. And if we subtract negative 3, that's equivalent to adding 3. And a number of the terms combined with others to make 0, x squared minus x squared, the plus 5x minus 5x, and the minus 3 plus 3. So in the next step, we write the survivors. Okay, so the survivors are 2hx plus h squared plus 5h, all divided by h. And every term in the numerator has at least one factor of h, so we factor h out. And we get h times the quantity 2x plus h plus 5 divided by h. We wanted to factor h out because we see that the denominator has a factor of h. So the simplified answer is 2x plus h plus 5. Okay, number 19. We're given f of x equals x squared plus 1 and g of x equals 2x plus 5 and h of x equals 3. Compute the following. So f of x minus g of x. So we'll write x squared plus 1. So g of x is a binomial, so you have to make sure that you subtract each of the terms. So if you don't write parentheses, write minus 2x minus 5. And we can simplify a little further, so x squared minus 2x minus 4 is what we get. Okay, part B, h of g of x. G of x is 2x plus 5, but h of x is a constant, 3. So as long as g of x is in the domain of h, and it is, g of x, the terms 2x plus 5 just range from negative infinity to positive infinity. And h of x equals 3 is defined from negative infinity to positive infinity. So it doesn't matter what the input is, the output is just going to be 3, no matter what. Okay, f of g of x, this is the notation for a composition of f and g, so it means f of g of x. So in the function f of x, we're going to replace x with what g of x is. So since f of x is x squared plus 1, f of g of x is what g of x is squared plus 1. And then we should expand this. When you square 2x plus 5, you get 4x squared. You get plus 10x once plus 10x a second time, and then plus 25 plus 1. And then simplify by combining like terms, 4x squared plus 20x plus 26. Part D, f times g of negative 1. This means to multiply f of -1 times g of -1. Okay, f of -1, since f of x is x squared plus 1, we have the number -1 squared plus 1, and g of -1, g of x is 2x plus 5, so g of -1 is 2 times -1 plus 5. So then some arithmetic. The number -1 squared is 1, and 1 plus 1 is 2. And 2 times -1 is -2. -2 plus 5 is +3. So when we're finished, we get +6. Okay, the next page. Number 20, parts A, B, C, and D. Find the domain of each function. Okay, f of x equals the square root of 8 minus x. We do know how to compute square roots of negatives, but the intent here is that the output values will always be real numbers. So that means 8 minus x has to be non-negative. So in other words, 8 minus x has to be greater than or equal to 0. And if 8 minus x is greater than or equal to 0, then negative x is greater than or equal to -8. And then if you multiply both sides by -1, this becomes x is less than or equal to 8. So just remember, whenever you multiply or divide both sides of an inequality by a negative number, you have to switch the inequality to its opposite. And then the interval notation for x less than or equal to 8 is parenthesis -infinity, comma 8 bracket. In part B, we have a simple rational function. So that there's only one restriction, x can't be 0. So the domain in interval notation, -infinity, comma 0, parenthesis, union, parenthesis 0, comma infinity. There's only one real number that's not in the domain. Part C, we have a quadratic function. Well, and it's just a degree 2 polynomial function. So for a polynomial function, the domain is always the set of all real numbers. So -infinity to infinity is the domain. And then part D is a logarithmic function. Remember that arguments of logarithms must be positive. So that means x minus 5 must be greater than 0, or x is greater than 5. And then the interval notation for x greater than 5 is parenthesis 5, comma infinity. Okay, the next problem, number 21. This one says a vehicle factory manufactures cars. The unit cost, capital C, which is defined as the cost in dollars to make each car, depends on the number of cars made. If X cars are made, then the unit cost is given by the function capital C of X equals 1.2 x to the second minus 768 times x plus 134,169. And the question is, how many cars must be made to minimize the unit cost. And then the directions on the final say do not round. Okay. Well, we see that we have a quadratic function with a leading coefficient that's positive. So we know that it has a minimum. The graph of that is a parabola that opens up. So to answer this question, we want to find the x-coordinate of the vertex. So the x-coordinate of the vertex is negative b over 2a. So in this particular function, a is 1.2, b is negative 768, c is 134,169. But we don't need to know what c is. So negative b over 2a, we get the negative of negative 768 divided by 2 times 1.2. Okay, so the negative of a negative is positive. So key that in. So x equals 320. So no rounding necessary anyways. Okay, so this means that if 320 cars are manufactured, that minimizes the unit cost. Okay, number 22. So I'll use the other sheet for that. Okay, number 22. Okay, so this says answer the following problem based on the graph provided below. The graph of the function g of x, graphed as a dotted graph, is obtained after applying certain transformations of the basic function f of x, graphed as a solid graph. And in part A, the function f of x is a parent function. So what is f of x? Well, this is pretty clearly the absolute value of x function. So f of x is the absolute value of x. Part B lists the transformations applied to the parent function to obtain the graph of g of x. Okay, so if you just pick a point on the graph of f and follow it, you can end up with the transformations. So starting with this low point on f of x, if we move to the left 2 units and then move vertically down 1 unit, that looks like that's halfway between 0 and negative 2. So there's move to the left 2, move down 1. So using the function notation, if I write f of x plus 2, this means move the graph of f 2 units to the left, and then a vertical shift downward is minus 1. So I think this is an okay answer for that. Oh, but part C, so since f of x is the absolute value of x, then f of x plus 2 minus 1 is, that's what g of x is. So this is the absolute value of x plus 2 minus 1. And then if you're in doubt about your function, well, you can test it. For example, when x is negative 2, replace x with negative 2, and you get 0 minus 1 is negative 1. So that appears to work. Okay, number 23. So I'll go back to a little bit larger print for number 23. Okay, this says let g of x be equal to x to the third minus x plus 1. Find the average rate of change of g over the domain interval from negative 1 to 8. So this is a definition that you should know, average rate of change. So the average rate of change of g on the interval from negative 1 to 8, notationally it means g of 8 minus g of negative 1 divided by 8 minus negative 1. And then g of 8 is what we get when we replace x in g of x with 8. So g of 8 is 8 to the third minus 8 plus 1. And we're subtracting g of negative 1. So put that in parentheses since g of x has 3 terms in it. So inside the parentheses, g of negative 1, that's the number negative 1 to the third minus negative 1 plus 1. And then we're going to divide it all by 8 minus negative 1, which is 8 plus 1. Okay, 8 to the third, that's 8 times 8, 64. 64 times 8 is 512. Minus 8 plus 1, minus, and then we'll do some arithmetic inside this set of parentheses. The number negative 1 to the third is negative 1, and we're subtracting negative 1, that's plus 1, and then plus 1, all divided by 9. I suppose we can do more than one thing at once. 512 minus 8 is 504. 504 plus 1 is 505. And then inside this set of parentheses, negative 1 plus 1 is 0. 0 plus 1 is 1. So we're just subtracting 1. And then dividing by 9. So 504 divided by 9 is 56. Okay, the next problem, number 24. This says list all the possible rational zeros of the polynomial function. So the numerator factors p, those are the integer factors of the constant 6, and then the denominator integer factors are they're the integer factors of the leading coefficient. Okay, so the integer factors of 6 are positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. The integer factors of 2 are positive and negative 1, positive and negative 2. So the candidates for rational zeros have the form P over Q. Okay, so P over Q, 1 divided by 1 is 1, so positive and negative 1. 1 divided by 2 is 1/2, so positive and negative 1/2. And then 2 divided by 1, positive and negative 2. 2 divided by 2 is 1. That's already accounted for. So then we shift over to 3. 3 over 1, so positive and negative 3. 3 over 2 is 3 halves, so positive and negative 3 halves. And then finally, 6 divided by 1, so positive and negative 6. And 6 divided by 2 is 3, but that's already accounted for. So these are the candidates for rational zeros. There might not be any rational zeros, but if there are, they have to come from this list. Okay, number 26. Identify both the vertical and horizontal asymptotes if they exist for these rational functions. So f of x equals x squared plus 2x minus 1 divided by x plus 3. The x plus 3 factor in the denominator indicates that there is a vertical asymptote. The vertical asymptote is x equals negative 3. There is not a horizontal asymptote. So say no. Instead of writing those out, I'll just say no horizontal asymptote. Okay, it doesn't ask for you to identify any other kind of asymptote, but there is a slant asymptote. And if you had to explain why, then you could say, well, the degree of the numerator is exactly 1 more than the degree of the denominator. And that means that the quotient is degree 1. And that means it's a straight line with non-zero slope. And that would be the slant asymptote. Okay, in part B, 2x minus 1 divided by x plus 3. Okay, we have the same vertical asymptote as we did in the previous example. X equals negative 3 is the vertical asymptote. And there is a horizontal asymptote. Since the degree of the numerator is exactly the same as the degree of the denominator, they are both degree 1. There is a horizontal asymptote. It's y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. But 2 over 1, we just write y equals 2 as the horizontal asymptote. Okay, in part C, f of x equals 3x over x squared minus 3x plus 2. We can easily factor the denominator, so we'll do that before we identify the asymptotes. Okay, there are 2 vertical asymptotes. One is x equals 1. The other 0 from the denominator is x equals 2. So x equals 1 and x equals 2 are the vertical asymptotes. And there is a horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, then the x-axis, or y equals 0, is the horizontal asymptote. Okay, we're down to about a minute and a half. We can start looking at number 27. Sketch the graph of f of x equals negative 1/4 x to the third times x minus 2 to the second times x plus 1. So I'll just point out a few things. Well, we have 2 cross points and 1 touch point. One of the x-intercepts is 0, 0. When x is 0, this factor is 0. And there's a cross point here at the x-intercept 0, 0. At x equals 2, there's a touch point because the multiplicity is even. And at x equals -1, we have another cross point. So let's see, the degree of this is 1, 2, 3, 4, 5, 6. It's a degree 6 polynomial, and the leading coefficient is negative. So the left-hand behavior is below the x-axis, and the right-hand behavior is also below the x-axis. But we'll start out with this one on Wednesday. We'll probably finish the sample final exam, but I'll have some other stuff to go over. That's all for today.